Hello, this is CIT 371, Linux System Administration. In this lecture, I'm going to be talking about Docker containerization. So, as I just said back there, this lecture is all about Docker. We're going to explain what it is and how it works, and why we would want to use it. In speaking about Docker, the platform, I'm going to be talking about what it does, which can be summarized in one word, containerization. I'm going to talk about containers and the process of containerization. In addition, I'm going to be covering the Docker Containerization Lab a little bit once I finish the other topics of this lecture. So, what is Docker? Docker is an open source containerization platform. It is used for running, developing, and deploying applications. So, it is focused on the development of applications and running them. So, you may be thinking, well, why would we want to use it? The reason being is that Docker supports containerization. So Docker creates these environments called containers. They are isolated processes that provide a secure space on a physical or virtual host to develop and run applications. So you can think of a container as like a isolated environment that your application is running in. It's more secure than just installing it on a server or natively on a server. So there's the benefit security and isolation there. Docker actually creates a network on your computer after you install it, and the containers that you create are actually put in this network by default. So running a container is comparable to running a virtual machine. So containerization is similar to virtualization, but on a smaller scale. So virtualization involves emulating the physical hardware components of a computer to run a virtual one on a physical host. So for example, you can have a server running multiple virtual machines, which is what we do for our virtualization platforms like what we used to use, CIV Center, VMware, and now we use Proxmox. Containers, though, are that but a little smaller. Basically, they don't need their own kernel, drivers, or other dedicated hardware software components. So a container doesn't have those pieces or computer parts. They're basically just what an application needs to run. It's basically just an application itself. It is important to note that Docker is free for the most part, but there are multiple tiers of paid versions, or multiple tiers of paid service or paid features. We won't be talking about those in this lecture or covering them in this course. Those are more important if you're a developer in a team that needs that kind of power or a business. So we're simply focusing on what is free. Here's something I want to clarify in this lecture. You may hear Docker image and Docker container used. It's important to know the difference. So basically, an image is a template used to create a container. So you can think of a virtual machine template that's used to create virtual machines, which is how we create the class VMs for COI. We have templates based on what professors make for their courses, and we make VMs from those templates. So it's important to note that a Docker image could actually be an operating system like Ubuntu and CentOS, but it's typically like Apache or OpenLDAP. It's just an application running in that isolated environment. Docker does have a repository of official images, so some of how Linux distros have repositories of like packages. Docker has a repository of official images or templates that you can download to run applications. It is true that people do make their own unofficial containers, but you should be careful when you use these because some can be malicious. You can get viruses from them, and they can do harmful things to your computer. So it's better to take from the official Docker repository whenever possible. Now there's container. Container is a isolated, runnable instance of an image. Containers can be created, configured, started, stopped, and deleted. Containers configurations are based on the image that is run from. So similar to a virtual machine, when you make it from a template, it's going to have all the same configurations that were made in that template. The thing of it is that you can configure containers. You can actually customize your containers with like YAML files and then run them. You can also customize containers to make your own images. We won't be covering that in this course, but that is something you can do. So this is good and all, but why would you want to use containers over just installing an application directly on a server? Containers have a lot of advantages. So the thing of it is that containers can allow you to host an application without having to install it manually. So if an application is really hard to install, like Nagios, or takes a long time, you can just run a container of a pre-installed image of that application, and boom, it's done. And it's right there ready for you to use. It takes literally a few seconds compared to like minutes and minutes of installation time. So containers also allow for easy and automated implementations of an application throughout a network. Basically, what that means is that you can basically run a container from an image multiple times, and you can put that throughout your organization if need be, like different clusters. Saves a lot of time. It saves a lot of employees' time, and it saves the company money because those employees can do other things. Containers are also enforce consistency. So if you build containers from a single image, they should theoretically be the same every time. Instead of having to manually install an application over and over and over again, you could just run multiple containers and it'd be the same. So containers also provide, as I mentioned before, a secure, isolated space to develop applications, which you can then convert into a custom image. Finally, containers allow many different services to each run their own container on one server. So you can have like Apache, you can have FTP, you can have OpenLDAP. Actually, what we do here at NKU is host a lot of different websites and certain applications on one Docker server. So it saves, instead of having to build multiple servers that each host this one feature, you can just have a Docker, one server host multiple containers, and each of these services will be isolated on their own container. Saves a lot of money by reducing the number of servers you need. Also, the amount of resources needed too. So installing Docker. So Docker is open source and free to download from its website. Um, I will say that you got to be careful when you install Docker. You need to pull from the um, Docker Engine article for installing on a Ubuntu. If you do Docker IO and other unofficial packages, they do have a lot of compatibility issues. Please use the official article, the official instructions to install Docker. Um, Docker does have a repository you can install from. You can install from source, but it's easier to install from the Docker repository. You should note it should be noted that you're installing Docker Engine. So this installs the terminal-based capabilities of the software. There is Docker Desktop, but I don't believe it's free. Also, we won't be using it in this course. We're just going to be using the terminal version. There's also Docker Compose, which you can run multi-container applications, but we don't cover that in this course. Now, deploying containers. To deploy a container or run it, you simply use the docker run command. Throughout this lecture, the rest of this lecture, there's going to be commands bolded. You want to pay attention to those for the lab. If you run commands, if your run command or docker run command specifies an image that does not currently reside on your server, the good news is that Docker can automatically download it from the repository and deploy it for you. Docker run command supports a variety of options that allow for the following configurations. So when you run this command, you're going to be configuring your container in certain ways. For example, you can name it, you can map a firewall port to it. And this is pretty important if you have a web, an Apache or another web server application. You can map that. You can map access to the application through a certain port, like 8080 is pretty common for the Apache container. So you can also map container directories to ones on your server hosting the container. This allows you to make configuration files accessible without accessing or entering the container. It allows you to host files on your server that are used by the container. The latter is going to be the case for the lab. So finally, the docker run command, you can configure to open an interactable shell in the container, allowing you to directly configure the container. This is very important here, listing containers. Now, I've noticed throughout various semesters that students will accidentally create multiple containers from the same image, like multiple Apache containers. Use the docker ps command or ps-a command to list all containers, and you'll see which ones are running. You'll see the following information when you run this command. Your container will have an ID. This is important because it's a unique string that identifies the container. Now, if you have to remove or stop and remove a container, you want to use either the ID or the name. The image that the container comes from is also listed, as well as the command that was used to run the container. the time that it was created, in time that it's been alive or running are also provided. Ports that are bound to the container are also listed. And then finally, you can add a friendly name. If you don't want to type this container ID, you can actually specify a name. Now, if you don't do that, Docker is going to provide some silly random one like Upbeat Panache. Yeah, Docker likes to add silly names or two-word names to containers if you don't name them yourself. Now, when you need to delete a container, you take this thing here, this container ID or the name, and you stop it and then delete it. We're going to cover that in a minute. So to manage a container, most commands require you to provide the ID or friendly name, as I mentioned before, followed by the command. This includes the following. To stop a running container, use the docker stop and then the container ID or name. To force a container to immediately stop running, you can do docker kill. Docker restart restarts the container. Docker start starts one. Now that's separate from run. When you do docker run, you're creating a container. Docker start is what actually starts an existing container. Now finally, docker remove or RM is how you get rid of it's how you delete a container. You can't delete a container unless you stop it first. So if you're going to delete one, you got to do docker stop and then docker RM. These and more containers are going to be in this Great Learning article here. Great Learning. That's the name of the resource. But it is also for great learning, I guess you could say. Okay, lab overview. In the Docker Containerization lab, you're going to run a container for Apache, which is an open source web server application. It's one of the most widely used web server softwares. There's also Nginx, which is probably as, or if not more, popular. Apache is it's pretty simple for what we're doing in this lab. In a native installation, Apache hosts web server content in var www.html. That differs depending on the distro you install it from. CentOS is going to be different than this Ubuntu folder here. So in the lab for this module, you're going to map a folder on your server to the var /var /www/html folder in your Apache container. So this folder that's on your server, Ubuntu server, is going to be one in your /home/student directory. You're going to make a directory in there, and then map that directory to this one residing in the container. And then in this container on your server, you're going to create a custom web page using the basic HTML code. So please be very careful that you map the folder. If you just map this container folder to /home/student, the website will be inaccessible due to permission issues. Now, if you create a folder within /home/student and edit the permissions, you're going to be able to access the website then. Very important to note. But anyway, that's the end of the lecture. I thank you very much for listening, and I hope it was helpful. If you need any help with the lab or understanding anything in the lecture, please let me know. Thank you and have a wonderful day.